Now I want to kind of go over the operation of the system itself, and the safety devices included, and we'll go over the safety first. This can be run as an open or a closed system. Mine's a closed system, so I run with about 25 pounds of pressure. There's two 30 psi pressure relief valves. There's actually three. There's also one on the 6-gallon mixing tank. And as far as the stove, shutting the stove down, there's three ways that this stove will shut off. One is through the room sensor. This particular stove uses a room sensor, and with a 25-cent modification, it's now set to read water temperature instead of air, and I've got it set at 170. So if the water would get above 170 degrees, the stove would shut off. Also, there's a thermostat in line with that, so I could shut the stove off and on from upstairs. And there's a third way to shut this off with the there's a high limit aquastat that's hooked to the power of the feed motor. So if it's above, the water gets above 180 degrees, it'll interrupt the power to the feed motor, shutting it off and killing the fire. Now for the operation of the system, we'll start with the 6-gallon tank. This is optional. The purpose of this is to mix the hot and cold water, the incoming water and the outgoing water, before it goes into the corn stove. And it's also used for just to have a volume of water. You need a good volume of hot water to run through the furnace. In certain situations, certain setups, this is not needed. If you're running a radiant floor, you already have enough volume, so you wouldn't need this 6-gallon tank. But starting here, the water would be pulled from the 6-gallon tank. Typical motor or a pump used for this setup would be a Taco 007. I have a 3-speed just because I was kind of playing with the settings and tweaking it a little bit. So from there, the water is pumped into the stove through the mixing plate, then through the coils, and then it comes out, travels through the 3/4 inch copper pipe. The hot water comes up to the water to air heat exchanger that I installed in the furnace plenum, and then it'll come back to the 6-gallon tank. Now there's an aquastat on the water line here that's hooked to the furnace fan, and what that does is when the water temperature coming in is 160 degrees, it'll turn the furnace fan on, and when it drops down to 140, it'll shut the furnace fan off, and it'll take about 5 minutes to bring it back up to 160, and then the furnace fan will run another 4.5 minutes, and that'll just cycle like that to where I'll get 5 or 6 cycles an hour. This here is a display of the difference between the outgoing and the incoming water. Right now it's picking up about 12 degrees. And this will depend on the size of pump you're running. I've got a little bit bigger pump than I need on here. If this was a 007, it would be closer to probably a 17 or 18 degree difference. And I'm running at a fairly low feed rate right now. With a maximum feed rate, you can get close to a 40 degree rise through the stove. I've never had it up to that point yet. Something I forgot to mention here is before it comes up to this water to air heat exchanger, it goes through a tube and tube heat exchanger that I made here, so that 160 degree water from the corn stove heats the water in the 30-gallon water heater just through natural thermal siphoning. So if I run this when I get up in the morning, I have a tank of 160 degree water, and obviously that's not a safe temperature to send upstairs, so there's a mixing valve hooked up before it goes upstairs, so the hot mixes with the cold, so it's sending 110 or 115 degree water upstairs. So in reality, this 30-gallon tank is really more like a 40 or 42 gallons of hot water, since it mixes first. So it really helps. It provides all the domestic hot water we need. We use it in the morning. By the time we get home from work, this tank is reheated to 160 degrees and it's good to go again. So once again, I haven't used really enough LP to even be able to see the difference on the gauge outside, so that's pretty good. So now that I have the heat going through the house's ductwork, I can really control where it goes, what rooms get heat, which rooms don't. There's some rooms I don't use that much, so I have the dampers closed a little bit. The duct that goes up to the bedroom, I've installed a thermostatically controlled damper and a thermostat up in the bedroom, so when it's 68 degrees up there, the damper will close and it won't open again until it calls for heat. So it keeps the bedroom at a consistent temperature all the time, which is very nice. And then of course, since we're using the ductwork, we're taking advantage of the whole house humidifier, which is something I've never had until this year, and it's really a big difference with the winter air being so dry. To have humidity up there, we can actually turn the temperature down a few degrees and it still feels nice. This system, I've got it fully automated now, so I kind of went through the wiring, the safety, the aquastats. It's hooked to a Wi-Fi thermostat upstairs, so I can shut it off and on from upstairs, and since it's Wi-Fi, I can actually turn the stove off and on with my phone wherever I'm at. So a lot of times I'll turn it off when I'm gone, and I'll turn it on a half hour before I get home, and the house will be up to temp. So one of the most satisfying thing about this whole setup is the fact that we're now heating the whole house and the domestic hot water with wood pellets, made right here in the US. We're not paying for any LP, and that's just a good feeling. Thanks for watching the video. If this is something that piques your interest, you can find out more about them on their website. I believe it's just www.crosslinkconversions.com.